Today I'm going to show you how to create your first Lambda function in AWS account. And if you have no idea what AWS Lambda Function is or when you want to use it, then go and watch my previous video. For now, let's go and log into AWS account, and usually you can just do that from aws.amazon.com, click and sign in, and it should prompt you for the username and password that you have set up. And if you don't have an AWS account yet, I also have a video on that as well. Once you're logged in, you should see this console homepage. Whenever you log into your AWS account, it's called AWS Management Console. Basically, it's where you manage all of your AWS resources. And what we're after is the search bar, and we are going to search for Lambda. Here you would see a list of functions that you already have. As you can see, I have one right here, but we're after creating a new one. After we click this Create Function button at the top right corner, we're going to be presented with different options about how we want to author it. So here we can author it from scratch. If you already know the workflow that you want to run, you can use a blueprint and it will create things for you. The limitation with blueprints is that it looks like it's only available for Node.js or Python. So if you want to write your code in a different programming language, then it really isn't an option for you. And this last option is the container image. And what it allows you to do is run your whole application in a container using Lambda. And one of the use cases when you may want to consider a container image is when your code grows beyond 250 megabytes in size, because that's the limit that Lambda lets you upload your code as a zip file. We're not really going to worry about this option for now, but the procedure is going to be the same regardless of what you choose. So we're going to choose author from scratch and just go through each of the options. So for the function name, we can just say codevev hello, and notice that you can only use letters, numbers, hyphens, or underscores, and it will tell you if the name is not valid. Then we're going to choose the runtime, and I'm actually going to choose Python just because it's simpler for demos. Then the next interesting option is architecture, and we can choose between x86-64 or RAM64. And here, most of the times, you can just leave it as default, unless you know that your application is optimized to work with ARM64 architecture. But the differences between these two is really a topic for another video, so I'm not gonna spend more time on this. Then you may want to look at this option to change default execution role. And again, we're presented with three different options. We can create a new role with basic Lambda permissions, and basic Lambda permissions is basically giving your Lambda access to your CloudWatch account to publish logs. That's the default permissions usually. You can also use an existing role. For example, if you already know what your Lambda function is going to do and which permissions you need, you may have created what's called an IAM role already and defined the exact policy that you may want. And then lastly, you can create a new role from one of the templates. If you know how you want your Lambda to run, then you can just choose one of the policy templates. For example, if you want your Lambda to access files in your S3 bucket, then probably would want Amazon S3 object read-only permissions, but you can also choose any of these options later whenever we create what's called triggers, and we'll get to triggers in just a second. For now, we'll just create a new role with basic Lambda permissions, the easiest route. Then we can take a look at the advanced settings, but really we don't need to change any of them. So one of the options is to enable code sign-in. Basically, if you check this option, then your Lambda won't run unless your code was signed. And actually AWS has this service called, I think it's called AWS Signer, and you can read on this later. But again, this is really not in scope for this video, so just leave this option alone. The next option is to enable function URL, and this will let you trigger this function via an HTTP request from Postman or browser. Usually you don't want to do that. If you are using Lambdas to create like an API for your application, then you probably want to use API Gateway instead. But this is a good option if you just want to play around and test the function or figure out how it works, whatever. Then the next option is enable tags, and tags is basically what it is. Just think of like Twitter hashtags. You can tag your resources. So for example, if you're creating an application that has several resources, you can tag them. And then whenever you go to billing or whatever, or if you decide to delete these resources, you can find them by the tag, and then it's just easier to manage them. And then last option on here is to enable VPC. VPC stands for Virtual Private Cloud. And by default, a Lambda is already in a VPC. As you can read here, it's inside a default system managed virtual private cloud. But a lot of times your resources such as database, cache, and etc. may live in their own private cloud inside AWS. And if you do have those resources, you may have to enable VPC in order for Lambda to access those resources. But again, VPC is a really big topic, and we will probably discuss it at some point in the future. So in the end, just leave all of these options unchecked unless you want to enable tags, and then let's create a function. And now we are presented with this function overview screen. So you can see quite a few options here. This function ARN is your function identifier, and you may want to use it if you're defining more IAM policies later on. Obviously, this is gonna be your account number, it won't just be all access. And then we also see that some code was already generated for us. And this will allow us to test our function. The way Lambda works is it needs your code to have a handler defined. And a handler is just basically a method that accepts certain type of arguments, and then whenever the Lambda function gets triggered, then your code gets executed and these arguments are passed into your handler. So here we can see that we got the event and the context. And what we can do is just print them and see what they look like. So I got this event, don't forget the F for string interpolation, and then print F. I got this context and then context. So if we change anything from here, then we can just click deploy. Alternatively, if you already have code that you want to run that you maybe built locally, you can just upload it from either a zip file or Amazon S3 location. For now, we're not gonna worry about that. We're just gonna test this function. So if we click test, we're prompted to configure a test event. For example, we may wanna save it if we want to use the same one in the future. We can just click invoke here. And so now we see that our Lambda function got executed, and we see that we got the response code, and we got a body, hello from Lambda, which is because we are returning it from here. And then we can also see that we recorded this event, and then we got this context, which really isn't very helpful for us. Most of the times we don't need to worry about the context. Mostly we're only concerned with the event and the values in the event itself. But obviously that's not what the Lambda functions are for, to manually click the test button. We need to configure what's called a trigger. And a trigger is basically something that happens which will make your Lambda function execute. So if we go to configuration, we can either click add trigger here or click triggers and then click add trigger right here. And we can see we need to select a source. And there are like plethora of different options from AWS as well as third-party sources. So maybe you're familiar with Shopify. So you can configure your Lambda function to get executed based on something that happens in your Shopify store. Today, we're going to create a very simple trigger, and we're gonna use Event Bridge. And the reason we're gonna use an Event Bridge is because it will allow us to create a new rule, which will have our function run every minute. So for the rule name, we can just say once a minute. Description is optional, but we can be good citizens and still say once a minute. And then as a rule type, we can either define an event pattern, and we could do that if we wanted to rely on certain types of events and certain values inside the events. For now, we only need to care about schedule expression, and there are two ways to configure it. We can either use cron or rate expressions, and rate expressions are easier to write. So we can just say rate and then 1 minute. It's just more humanly readable format. So we create a trigger. And again, if you want to use any other trigger, the process would be very similar. You will just click add trigger, select a different source, and just follow the prompts to configure it. And now we click the add button, and the trigger is gonna show up right here. Now we won't know if the function has run yet, because it usually takes about a couple minutes for the logs to be uploaded to CloudWatch. So while we are waiting for that, let me show you the permissions tab. Whenever we created a function, it created these permissions. It created the permissions to allow creating a log group, creating log streams, and putting log events. After we added a new trigger, we also got this new policy statement from events.amazon.com principal, which is the event bridge, and then the action is to invoke a Lambda function. That's why I said we didn't really need to configure all of those permissions in the beginning. We could also either add them later or let AWS handle it for us when we add a trigger from here. So now if we go to the monitor tab, we could see metrics, logs, and traces. And here you can see that our function, let's see, 12:43. What time is it? It's 12:45. I think it's still the one from our test. So let's look at logs. I'm pretty sure it's still the one from our test, but every minute there will be a new invocation, and ideally we should see more logs here. Okay, so now we are refreshing again, and as we can see, we got a new execution and we didn't really have to do anything. So now we just click the log stream, and we can see that, let's see, it's 12:40 is when we got our function executed. Okay, so I guess the last one was the right execution. So we got one at 12:43, then we got one at 12:44, at 12:45, and we can see that it prints, I got this event. One interesting thing you may notice in these logs is this request ID and the build duration. So the way Lambda gets billed is the following. You get 1 million free invocations per month. You also get 400,000 gigabyte seconds a month. And what gigabyte second means is basically your memory size times duration. So in our case, if we wanted to calculate how much our function would have cost us to run if we exceeded our free limits, we could just say, let's see, 002 times 0.128, because it's gigabyte per second, not megabyte per second. And then we will need to multiply it by whatever AWS Lambda cost is. So if we look here, you can see the Lambda pricing. So we're on x86, and then say it's our first 6 billion gigabyte second. So we're just gonna get this value. And so we're gonna multiply it by this value. So that's really not that much. This number is obviously negligible, and that's the whole point. We want something that runs on demand and doesn't cost us much, versus, for example, if we had a virtual machine, or EC2 in AWS terms, running all the time, then we would get billed for all of the time it was up, regardless of whether it was doing anything or not. And also notice that once we go over 1 million requests, it's only 20 cents for each other million requests. Pretty decent pricing. Now let's go to our configuration and go to general configuration. And as you can see, this is where we can change the memory. So for example, if your code is more memory intensive or CPU intensive, then we can change this memory value. And notice we only change one value for both CPU and memory, because if you click this info button, it will tell you that allocates CPU power linearly in proportion to the amount of memory configured. So we could always just change this. We could always change the storage. Ideally, you may not want your Lambda function to have any state, but if you're maybe downloading some files from the internet and you're downloading some big files, maybe that's not enough, 512 megabytes. And then an interesting option is this timeout. And currently it's set to 3 seconds, which obviously works because our code doesn't do anything except printing hello or whatever. But the maximum timeout you can configure in your Lambda function is 15 minutes. And as you can see, the maximum timeout is 15 minutes. And really, if your function runs even that long, then you probably have a problem, either in your code and you need to figure out the bottleneck, or you just need to figure out a better solution other than running Lambda. So we're actually not going to change anything here, but you know where to change things if you wanted to. And that is pretty much everything you needed to know about creating your first Lambda function. If you were following along, I would recommend deleting the resources, and at least make sure to delete this trigger, otherwise it will run every minute and you don't want to accrue any costs. Costs would probably be negligible, but still, let's just clean things up. So we're gonna delete this, then we're gonna delete the function itself. And now we can also go to Event Bridge and delete the created rules. So here we click rules, once a minute, delete. Let's also check that we didn't have any roles that we need to delete in IAM. And actually we do. So probably, I think it's these ones. I've tested this before as well. So I'm gonna delete just all of them. The IAM roles won't really hurt you if you don't delete them, but just to keep it clean, let's do that. And if you want to learn how to do all of this without leaving VS Code, then watch the next video.